Question 2 in the 2021 Kinematics Topic Test. Particle moves in the xy plane such that, so I have an I component and a j component, and that's r dot. Therefore, that is velocity is going to be that. I've got to find the speed when t equals 1. So the velocity when t equals 1 will be 9 minus 3 times 1 squared is 6 in the I, plus log base e of t is 1. 1 minus 3 is negative 2 to the power of 4 is 16 plus 1 is 17 in the j. So the magnitude of the velocity at time 1 will be the square root of 6 squared plus log base e of 17 squared. Remember, it's the logarithm squared, not the 17 squared. And throw it in the calculator and you get 6.63529. And I need two decimal places. 6.64 meters per second is the speed. Okay, part B, when is the particle at rest? Well, the particle is at rest when velocity is equal to 0 in the I and 0 in the j. It's got to be 0 in both of them. So what I'd like to do is I'd like to set these equal to 0. So 9t minus 3t squared equals 0. And log base e of 1 plus t minus 3 to the power of 4 equals 0. That will equal 0 when 1 plus t minus 3 to the power of 4 equals 1, because log base e of 1 equals 0. So solve both of these on a calculator or by hand. I can take out a t, I can take out a 3t. That's going to give me 3 minus t equals 0. Therefore, t equals 0 or t equals 3. They're the two times that the I component will equal 0. And t minus 3 to the power of 4 equals 0. Therefore, t equals 3. The only time that this is equal to 0 is when t equals 3. Since both components have to equal 0, therefore t equals 3 is the only time that the particle is at rest. Part C, find the gradient of the curve when t equals 1. Okay, so to find the gradient, I need to find the direction. And to find the direction, I'm going to use the velocity, because the velocity will tell me the direction that it's traveling. So v of 1 is going to equal, this is v of 1, so it's going to be 6 in the I plus log base e of 17 in the j. So the direction that it's going will be this direction, where that is going to be 6 in the I, and that's going to be log base e of 17 in the j, and that's the direction it's traveling. Therefore, the gradient is going to be the y component or the j component, log base e of 17 all over 6, and I'm going to find that to two decimal places, and that's going to equal on my calculator 0.4772. Therefore, the gradient equals 0.47. And lastly, find t. When t equals 1, the particle is at point P. Given that find the y coordinate of point P. Okay. Okay, so I know that y equal 2 at t equals 0. I've got to find out what y equals. So what I'd like to use is that out of 9g, using a definite integral to solve a differential equation. So I'd like to integrate from 0 to 1 of the j component and then plus 2, because I knew that it was at 2. So I only need to integrate the j because it's only of the y coordinate. So I'm going to integrate log base e of 1 plus t minus 3 to the power of 4 dt from 0 to 1 plus 2, because I knew that it was 2, and this will give me the change in the y value. Now, when you're entering this in the calculator, my cursor at the moment is still inside the integral. So if you come across one, notice you now have a big flashing cursor. Now I can plus my 2, which is outside of the integral, and that gives me an answer of 5.6669. And to 2 decimal places, the y coordinate should be 5.67. And that's question number 2.